First of all, I'm so sorry for the yesterday, right? I'm still stuck in the traffic. Actually. CCIE services. Okay, right. So I haven't said you the config file of the IPsec, what we call dynamic BTI1. I will say it by tomorrow, maybe the day after tomorrow, right? Okay, I put the configuration in on different laptop, right? It's not there with me. I will share with that config. There was a simple mistake I did on the hub router, right? So does anybody has any question in the, I know my voice or something's happening right now. Does anybody has any question in the VPN? Anybody has done the lab of the IPsec, SBTI, DBTI, or the DME pin, GREM, GRE, or DME pin over the IPsec, GRE over the IPsec? Anyone has any questions?
The DVTI configuration, did you find that one?
Yeah, either find it. I will share with you. Maybe the tomorrow or day after tomorrow, right?
Okay.
I have it in my laptop. Yeah, I found it.
Okay.
All good apart from that one?
Yeah, apart from that.
Okay, great. Now, today we are talk of starting the concept of the VRF, right? What anyone know what is VRF? Anyone has any idea regarding the VRF?
Different, like just like VLANs, splitting the
Right? Good.
routing domain to different routing domains.
And why do we need of VRF?
For having different routing table.
And why do we need a different routing table?
To separate the routing table of customers.
Okay, that's a good one. To separate the routing table for the customer of the customer. And why do
in
we
the
need
same router?
on the same router?
Same
Yes,
like yes, the same
on
router.
the same router. And why we have to do this thing?
To segregate the.
To segregate, right? Why do we need to segregate the route? Okay, let's talk about the
Security?
sorry, go ahead. Go ahead.
For security?
Security, what kind of security you are getting that?
Like customer domain, like one customer domain will not be communicating with the other customer.
That you can also do with the filtering.
Mm-hmm.
That you can also do with the filtering. BGP has a lot of options, right? BGP, right? You can assign the different process
Roadmap.
as well.
Yes.
EHRP number 1 for the customer 1, EHRP number 2. Not a big problem, right? So even if you're going to assign the different process ID, the route will be not leak from one process to a different process by default, right?
Yes.
Okay, let's focus on the VLAN. Basic CCNA. Why do we need a VLAN on the switch? To reduce the broadcast domain, right? So
Yes.
the flooding will be not happen in the complete broadcast domain. So dividing the large broadcast domain into the small domain called as a VLAN, right? Simple language. What VLAN is basically doing that by default, right? By default, what happened? Whatever the ports on the switch right now, every port doesn't matter. So let's example, we have a PC1 over here, right? We have a PC2 right now, the PC3 right now, and the PC4 right now. We have a 1/1, 1/2, 1/3, 1/4 right now. So whatever the ports that you see over here, by default, all the ports are the part of which VLAN?
Native.
VLAN number 1, right? The native VLAN. So if the person A will send any broadcast topic, it will be listened by all the user. So if this guy will send the broadcast topic, it will listen by this guy, and this guy as well, right? What I'm gonna do that? I'm gonna segregate the, right? I'm gonna divide this large broadcast domain into the small one. How do I do that? I'm gonna combine this guy into the one broadcast domain. I'm going to combine this guy into the different broadcast domain. So I can call this guy, say, hey, listen, you are the part of the broadcast domain VLAN number 10, and you are the part of the VLAN number 20. What happened in that case? So we are going to allocate, okay, 1/1 and 1/2, guys, please pay attention, is a part of the VLAN number 10, and the 1/3 and the 1/4 will be the part of the VLAN number 20. Is it good? So eventually what happened, all the ports will be disappeared from the VLAN number 1. Nothing will be there. Now, the thing is that now if I'm going to send the broadcast traffic from the PC A, right, it's only going to listen by the PC number B. It's not going to hit by the C and D as well, right? So no traffic will be happen in the C and D. We can say the VLAN number 20. So the broadcast is only happening in the VLAN number 10. And if this guy is going to send the broadcast is only happening in the VLAN number 20 only, dividing the large broadcast domain into the small one. How it's happening? The reason behind it,
VLAN tagging.
not VLAN tag. Access port does not perform any kind of tagging.
Uh,
So by default, what happened on the switch side, right? By default, what happened on the switch side, we have a MAC address table, right? So if I talk about in a default way, what happened, you have a, if you put the command show MAC address table, then what happened, you will have to see the MAC table over there. That's called as a global MAC address table. That's called as a global MAC address table. In the global MAC address table, what happened, you will see all the MAC addresses, right? So let's example, I'm gonna assume it the 1/1, the MAC will be A, 1/2 MAC will be B, 1/3 the MAC will be C, and the 1/4 the MAC will be D right now. Assume it. They are the part of the VLAN number 1, no problem. But as soon as I'm gonna create the different VLAN number 10 and 20 on the switch side, in the backend what happened? Switch will create the separate MAC address table for the VLAN number 10 and the VLAN number 20. So now you have a 3 MAC address table. One is for the global MAC address table, which is called the VLAN number 1. Another is called the VLAN number 10 and the 20 as well. So as soon as I'm gonna associate the port into the particular VLAN, the 1/1 and 1/2 is a part of the VLAN number 10, 1/3, 1/4 is a part of the VLAN number 20. Eventually, what happened in this VLAN number 1, there's no any ports now. So now this guy is part of the VLAN number 10 over here. Sorry, not VLAN number. User A belongs to the port 1/1. User B belongs to the port 1/2. Same thing. User C belongs to the port 1/3 and user D belongs to the port number 1/4. Is that clear? It seems like you can assume like a EIGRP topology table 1, EIGRP topology table 2. So by default, what happened, whenever the packet comes to me, let's example, if the A will send the packet to the broadcast FFF, the packet will hit to the MAC address table. In the MAC address table only, we have 2 users, A and B. So I receive the packet from A, I will forward the packet to the B, that's all. I don't have a C and D in this one, VLAN number 10. Same thing if this guy will send the packet. Let's example, D is the source, destination is B right now. Let's example, this is the destination B. The packet comes to the VLAN number 20 and say, hey, do I know the B in my MAC table? No, I don't have it. So in the backend, what happened? You creating the MAC address table. So if you're going to put the command show MAC address table, VLAN number 10, it will show you the VLAN number 10 MAC address table. If you want to see the VLAN number 20, you will put the command show MAC address table VLAN number 20, it will show you that. If you're going to put the command show MAC address table only, it's going to show you the global MAC address table. In the side corner, if you see that, depend on the modules by module. Sometimes what happens, we will say in the first column, second column, third column, fourth column. Eventually, everywhere in the MAC address table, you will have a VLAN number over there. Is that clear?
yes.
Now, question again comes, same thing. Why? So why we need a VLAN? Because I'm assuming we have an IT department, we have a management department, sales department, a different customer, anything. What are the beautiful benefits that you see over here right now? would happen. Is it possible? You tell me one thing. Is it possible that MAC A can be learned on the 1/1 and the MAC A also will be learned on the 1/3? Is it possible in the same MAC address table? Or duplicate MAC address? Is it possible in the same MAC address table? Duplicacy will be not allowed in the same MAC table. But if I'm going to do that this way, it's allowed now. Why? Because A is associated with the VLAN number 10 and A is associated with the VLAN number 20. It's perfectly fine, no problem. So when you have a duplicate MAC, normally it's very hard to find in production hub. So this is the one of the use case over here. So if somebody will ask, can I put the two MAC, duplicate MAC in the same MAC address table? No, you cannot do that. Create the different VLAN, you can do that. Now have a logic of the same thing. Why the duplicate MAC comes in the picture? Maybe this is the customer number A and this is the customer number B. That's fine. They manually change the MAC address. You have an ability, you can change the MAC address as well. So that's allowed perfectly, no problem. Now, same concept is happening with this is the layer 2 virtualization. Same thing I'm going to do with the layer 3 virtualization as well. The layer 3 virtualization is called the virtual routing forwarding. I'll explain the word of this line, everyone. Don't worry about that. But every word has some meaning right now. In VRF, what happened? Let's say example, right? Understand the requirement right now. I have a ISP right now. This is the router number 5, right? Okay. Yeah. All good. This is my router number 1. This is my router number 2. This is my router number 3. This is my router number 4. And this is my router number 5. I have, this is the customer A. You can assume it, or we can see the customer red. Right. That is belong to the Delhi site. We have a customer red as well in the different location, maybe in the Bangalore. Right. We have a customer blue as well in the Delhi. And the customer blue in the Bangalore as well. Right. Now, if I talk about this port that you see right now, we have a gig 0 by 0. Over here, we have a gig 0 by 0, gig 0 by 0, or 1, we can call it. 3, we have 0/2, we have, and 0/4, we have. Now, if I talk about, right, the subnet that I'm going to use between the router 1 and router 5, you can call it as a, 10.1, 15. Or let's go with the different way. That's 15.0/24. And this guy will have a, so of course the router 1 will be have a 15.1 and router 5 will have a 35.5. Sorry, 15.5. This guy will be 35.3. This guy will be 35.5, and so on. 25.0, 25.2 will be this guy, 25.5 will be this guy, and this guy go with the 45.0 as well, /24. Now, try to understand one thing. There's no problem right now in this situation, right? You just, customer has connectivity with the ISP, service provider router, and ISP has give the connectivity between the site to site. So customer Delhi can communicate with the customer Bangalore, right? From one side to the different site, right? Through the ISP. ISP has a lot of router. I just take example of the one right now, but assume that it's a big service provider, right? Assume it's a big service provider. Now think about, if you remember that we have a RFC 1918 address, right? The private and public address. Tell me one thing, right? I better to use the not the ISP. I'll better to use the MPLS one, right? MPLS cloud. So we have two types of IP addressing, the IP private and public over here right now. So as we know that the private IP address can be duplicated, right? That's one of the, good part. It's a free, I'm so sorry. It's a free, private can be duplicated. So if it is a duplicate, then this guy can utilize the 10.1.0/24, and this guy can also have a one public as well. Okay. Same thing, this guy can also use the same IP subnet, sorry, but this guy has a public is a different one. So private, you can see that between the customer red and customer blue have a same one. Same thing, customer red and customer blue, the private IP that you see that it's the same one. So if you see this part, same. This guy, same right now. All good? Now think about it. At the beginning of the class, I told you that, right? If I'm going to share this information, forget the routing right now, right? If I'm going to share this information right now to this guy, you need to understand this concept according to the private IP address concept. Public don't have problem. Public is always unique, right? So public IP address, we never have any problem. Private always have a problem. It's a free, so you have to, bear something. So when the router 1 is going to share this information to the router 5 through the any routing protocol, assume it we are sending through the OSPF. Again, I'm repeating that no matter which routing protocol you're using it, right? Even if you have a different protocol as well, they have a separate database table, no problem. But eventually, they have a single routing table. So if I talk about the routing table of R5 right now, what R5 will do that? They will learn this information from router 1 through the OSPF routing protocol as the OSPF O 10.1./24, and the O will have a /8. Same thing from the EIGRPS side of what happened. Router 1 has shared the information to router 5. Router 3 also going to share the information to the router 5. 10.1.D, the D4 EIGRP. And D will be 2.0.0. Again, I'm repeating that they both have a different database table, right? They both have a different database table right now. OSPF has a separate table on the router 5. EIGRP has a separate topology table on the router 5. But eventually, they have a common routing table. One router, one routing table. This routing table that you see, it's called a global routing table. And by default, like that, we have all the interface are participating into the VLAN number 1. Same way, what happened, all the interface on the router 5, these interface, this interface, this interface, this interface, all they are participating into the global routing table. Sometimes in a production network, you heard this term, default VRF. Okay, platform by platform basis. Again, I'm repeating that. Platform by platform basis, product by product. Sometimes people are used to call it the default VRF as well. So if I talk about the Nexus, if you're going to do that, by default, all the interfaces are part of the default VRF. Management ports are part of the management VRF. But I'm talking with the IS perspective right now, all the interfaces are the part of the global routing table. They do not use the concept word as a default VRF. Every ports are the part of the global routing table. Now tell me one thing. What do you think? Is it a correct routing table right now?
No.
No, right? So which route will be deleted?
EIGRP, which is
EIGRP has a 9080, OSPF has a 111080. So OSPF route will be deleted.
that will be removed.
This will be there, this will be there, this will be there, OSPF will be removed. This is the biggest problem we have right now. To solve this problem, what you can do that? To solve this problem, I have one solution. The solution is what? I can take a separate router, right? I can take a separate router. ISP will take a separate router 6 and give the one connectivity with the red customer. And he will give the also router 7 a separate customer. This one. No problem. So router 1 will share the own information to the router 6. And router 2 also going to share the own information to router 6. No problem. They can also extend the route from here to there and here to there as well. It means that you are getting a separate infra, right? You are getting a separate infra from the service provider. Is it possible that I can get the separate infrastructure for every customer? Is it possible that service provider can give the separate infra for every customer? A separate physical infra?
No.
Right? It's not a scalable solution. So doing the physical hardware boxes, it's not a feasible solution. That's why we came with the concept like that we have a layer 2 VLAN. On a layer 3, what happened? We came with the concept is called a VRF. One of the biggest myth of the VRF people has it. VRF create the virtual router. It's do not create the virtual router. It's create the virtual routing table. So you already have a global routing table, not to deny that. In the global routing table, what happened? You will have all these information. I will create the virtual routing table for every customer. So I have a customer, right? Let's make a one virtual routing table for the customer, right? I have a customer blue. I will create the one virtual routing table for the customer blue as well. This is again, it's a virtual. This is the logical one, not the physical one. So this routing table that you see, this guy is still gonna utilize the router resources, the CPU and memory. We are just creating the separate instances. That's all. It's not creating the router on the router. It's creating the routing table on the router. They don't have a own separate dedicated CPU and memory. Now, what is the need for this one? So in that case, what happened? The need for this one is what? So now, whatever the route that I'm going to receive from the customer red, I will put that route into the red customer. So 10.1.1.1.0/24, 10.1.2.0/24, which is coming from this side. Then we have a 1.0.0/8 and the 2.0.0/8. Same way, the side I'm getting the 10.1.1.0/24. This side I'm getting the 10.1.2.0/24. And this side I'm getting the 3.0.0.0 and the 4.0.0 as well. No problem. Duplicacy is allowed. Duplicate route is allowed now. Same like that in the VLAN. The duplicate MAC is allowed if you create the separate VLAN. So if you're creating the VLAN, it means that you're creating the MAC address table in the backend. Same thing. If you're creating the VRF, you're creating the virtual routing table on the router side. concept is totally same. How do you create the VLAN? You just need to go on the switch, say the VLAN 10, that's all. Same thing, how do we create the VRF? I just need to go on the router, say that, hey, listen, IP VRF, Cisco, or IP VRF red, IP VRF blue. So like that, you creating the VLAN number 10, 20, 30, I get the separate VRF, 3 virtual routing table app created now. Depend on the platforms, commands LAN are different. What you're doing after creating the VLAN, you just need to go under the interface. So hey, listen, this interface is the part of the switchboard access VLAN number 10. Same thing after creating the VRF, you need to map the port into the VRF. So VRF, you're going to deploy on the service provider end. So you need to map this two port into the red VRF. And you need to map this port into the blue VRF. So the first step is what? Like that VLAN, create the VRF. Second step is what? Because all the ports are belong to the default VRF, or we can call it a global routing table. We need to map the port into the particular VRF. If you're not going to map the port into the particular VRF, then there is no sense to create the VRF. 2-step in the VLAN, 2-step in the VRF. Layer 2 virtualization, layer 3 virtualization. In the layer 2 virtualization, what happened? We create the separate MAC address table. In the layer 3 virtualization, we create the separate routing table. Why do we need a separate routing table? The virtual routing table, the VRF, just to maintain the duplicate route. Why do we have a duplicate route? Because of the private IP address concept. If you have a public, there's no problem. No need to create the VRF. That's fine. But let me remove one of the biggest myth that people has it. Apart from the private IP address concept over here right now, duplicate route concept, you also require the VRF multiple places, even if you don't have a duplicate route. VRF doesn't mean that you are creating a separate instances for the separate customer just to segregate the route if they have a duplicate. Saying this at the CCNP and CCIE enterprise level, that's fine, right? As soon as you gonna move to the different label, right, you will get to know that VRF has a lot of use case. One of the use cases, I'll tell you that you have a read about this one as well, front VRF concept. The many use case you will encounter the VRF in your networking. When you go to the service provider label, you will find the many use case of the VRF as well. All good? You got the Yasir? Sebi, any question from your side?
No, it's clear.
No, like between the VRF, no, the routing thing and all we'll discuss later, right?
We can, that's not a big deal. We can link that up. We'll see that.
Okay.
In the MPLS L3, we'll talk about it. It's possible. Like that, we have a VLAN 10 to 20 communication. Same thing, we have a one VRF to another VRF communication is also possible. So in the case of VLAN, we call as an inter-VLAN communication. Here we call as an inter-VRF communication. Sometimes people used to call this as a route leaking from one VRF to another VRF.
Route leaking, right? VRF leaking, right?
Yeah, loudly.
Yeah. That will come later on MPLS.
Yeah, we'll
right?
talk. Yeah, we have a separate topic for that one. Now, how do I create the VRF? As I mentioned that same step, you need to go on the router. Step number 1.
And this VRF is local to the router only, right?
Yeah, that's a good catch. Look at that. So local to the router. Let me write down. And that's the case sensitive. Some setting. Okay, so in this picture right now, I have a 2 customer. I will create the 2 VRF. If you have a 3 customer, go with the 3 VRF. So I say the step 1, create the VRF, IP VRF red, exit from here, IP VRF blue, exit from here. Step 2, map the port into the VRF. How do I mapping the port? Remember one thing, whenever you're gonna map the port,
Hello.
I'm so sorry, guys. Got an emergency call. Yeah, so I was talking about the mapping the port into the V. Yeah, do you have any questions?
No, you were not audible for some
I
time.
don't know. I was talking to someone, right? So
Okay.
okay, so map the port into the VLAN, right? So map the port into the VRF. How do we do that? Remember one thing. Whenever you're gonna map the port, from one VRF, which is the default VRF, we can call it, or we can say that from one routing table to the another routing table, whatever the configuration will be there on this particular interface, whatever, all the configuration will be removed. This is the biggest mistake people are doing in the lab environment, the CCI lab exam, and in the production environment. I personally encountered that. One of my colleagues did that. Okay, so do not do that. So whenever you're moving the port from one VRF, right, to the another VRF, or we can say the global routing table to the different virtual routing table, because by default ports are part of the global routing table. Copy the configuration of that particular interface and then move it back to the another VRF. Okay, otherwise you will lose all the configuration related to the interface label. So the step number 2 is what? You need to map the port into the VRF. You need to go under the interface label. So the interface 0/0 as the IP VRF, right? Forwarding. So I'm saying that, hey, this interface is now going to forward the IP packet based on the which table? A red table. Listen to my statement. I'm saying that this interface is now going to forward the IP packet based on the red routing table, which is this one. Same way I need to map this port. Same way I need to map the 0/3 and 0/4 into the different VRF as well. So eventually what happened, I'll tell you. Eventually what happened, I have a blue VRF as well. Let me do that over here. This is my blue VRF in the bottom, right? So eventually what happened, in this red VRF, what happened, I will have a 0/1 and 0/2, right? In the blue VRF, I will have a 0/3 and 0/4 as well. If you just correlate this configuration with the VLAN, similar. In the VLAN as well, you create the VLAN, map the port into the VLAN. Is that clear? All good, right? So where's my topology? It's not there for me. Let me check with the different projects right now. VRF. This one. Or it's maybe this one. 39, 20.5. Oh wow, it's not popping up anymore. It should be there. Don't know. Let me add this route again. But that project was there. I remember that. So we have router number 1. We have router number 2 right now. I'll make it 2 over here. And router 3 as well. Router 4 as well over here. And router 5. So again, I'm repeating the same point. Never confuse with this terminology that VRF is only going to configure on the service provider end. You do configure the VRF on the customer side as well. One of the good example, front VRF. So right now we are going to do the configuration, right, on the service provider end. Customer side, we are not going to do any kind of configuration of the VRF. The reason we call this as a VRF, virtual routing forwarding, because based on the virtual routing table, right, they are going to forward the packet. Router is going to forward the packet. So they will receive the packet on the interface, and that interface is particular belongs to the VRF. So F0 by 0 and F0 by /0 is part of the red VRF, and this guy is going to part with the blue VRF. I'm going to write down over here. And the red VRF, we have a port number will be red table, red routing table, 0/0 and 4/1, 4/0. And in the blue VRF, blue routing table, we will have a F1/0 and F4/1. Now, if I talk about the IP addressing over here, I'm going to use the 15.0/24. The 15.1 will be router number 1, and 15.5 will be router number 5. Same way, 15.25.2 will be router number 2, 25.5 will be router number 5, and so on. (25.0/24). That's good. And now I can configure my loopback on the router number 1, where we have 1/0/8 L 10.1.0/24. This is the red customer in the Delhi location. Text edit, change the color. Right. I have a router 3 as well. This is my blue customer. That's belong to the 2.0, 3.0. We have a R2 over here. This is my Bangalore. And this is go with the 2.0. Same way what happened. Over here we have a Bangalore. This should be go with the 4.0. Here we have a Redmi. Right, that's all. Now, if I talk about the configuration wise, so this is my service provider SP. So on the configuration wise, on the customer side, we are not gonna do any kind of VRF. It's a normal configuration. So on router number 1, you can see that I have a config terminal. Interface 0/0 IP address will be 15.1/24. No shutdown. Interface loopback number 1 IP address will be 101/8. Interface loopback number 2 IP address will be 10.1.0/24. That's my private IP address. On R2, we have a on R2 we have a 25.2. When my loopback, we have a 2.2.2.2. And then my loopback number 2, we have a 2.1. R3 now. On R3, we have a 35.5. 35.3, sorry. This loopback will be 3.3 or 3.3. And this is go with the 101. Look back is my logical interface. This should be go with the 45.4. This should look back will be 4.4, and this should be go with the 2.1. Now the router 5, I intentionally am going to configure the IP address, which is, first of all, if you have a plan to configure the VRF, first configure the VRF and then map the port. That's a recommendation one. But I'm doing intentionally so that you will be knowing that what is the problem is happening, right? If I'm going to first configure the IP addressing and then VRF, it's extra work. So interface 0/0, 15.5. Okay, no shutdown. Interface 1/0. Have a 25.2. And here we go. Interface 4/0. IP address will be 25.5. And no shutdown interface. We have a F4/1. IP address will be 45.4. Oh wait, 45.5. I'm sorry. That's good. Now we have a loop back over here. I'm going to configure it just to show you the behavior. Now let me take a console of all the router. Okay, I'll copy the paste the configuration on the router number 1. That's my customer side. On R2 as well. On R3 as well. On R4 as well. I'm going to enable the debug on the router 5 just to show you the one behavior. Config terminal, and here we go. So I made a mistake, looks like. Yeah. This will be 25.5, sorry. 25.5. So you can see that whenever I assign when you assign the IP addressing on the interface, what happened? The router will find the subnet of that particular IP and they will add into the routing table. This routing table that you see, that's called the global routing table. You can call as a default VRF as well. Now what I can do that, I'm going to create the VRF on the router 5. How do I do that? Because on the customer side, we are not going to do any kind of VRF. On the router side, we are going to do the VRF. So if you see that right now, do show IP route, I have my single routing table. That's called the global routing table. I will get the VRF. I said IP VRF. That's a command. So the red, my VRF has been done. If you see in the backend what happened, I create my routing table red. Same time, I'm going to put the command IP VRF blue. I will get the blue routing table. Routing information base, that's a rib. But I just create the VRF right now, that's all. Right? I need to map the port into the VRF. How do I map it? So I need to go to the interface. This two interface 0/0 and 4/0 part will be the red routing table. So that's the interface 0/0 IP VRF forwarding red. All the configuration will attach to the interface 0/0 will be removed. I'm deleting the route right now. So I need to again configure the IP addressing over here. So remember this thing. So whenever you're gonna map the port into the VRF, right, your configuration will be removed, right? Your older configuration will be removed. So now you can see that red routing table, I'm updating this particular route right now. See, now you're gonna verify it. Do show IP route. This is the command to check the global routing table. Now in the global routing table, I do not have a 15.0 subnet, or we can call it the 0/0. It's not there. But if you not say the VRF routing table, you can put the command do show IP route VRF red. I will have a red routing table. Same way, I need to map the port interface 4/0 IP VRF forwarding. In which table? Blue, sorry, red only. I'm gonna map the IP addressing on this one, 25.5. Maybe at that time I configured the wrong IP. That's fine. Anyway, it will remove the IP addressing. That's done. Same thing, I'm gonna move to the interface 1/0. You can also use the range keyword if you want, so that you can convert the two ports into the VRF in a single shot. But I'm doing the normal ways right now. IP address will be interface 4/1 IP VRF forwarding. Blue IP address will be 25.5. No shutdown. And here we go, man. Now you can see that my ABD interface.
25 is in the red, no?
So, sorry?
25 is in the red VRF, no?
Oh, sorry, 45. Good catch. Show IP VRF now. You can see that I have a two VRF. Forget that this part right now, default RD. We'll talk about it. Blue and the red. Blue have a two interface. There's two one, F1/0 and 4/1. And the red, we have a 0/0 and the 4/0. You're gonna see the IP addressing as well. Show IP VRF interface. You can see that these interfaces are part of the VRF. Now you're gonna see the routing table right now. Show IP route VRF red. I will have a red routing table. Two route only, 15 and 25. So IP route VRF blue, I will have a blue routing table. 35 and 45. Now if I
Can we see global
go ahead.
routing table?
Yeah. So in the global routing table, if you remember that, I created the one loop back on the router, right? But I haven't mapped that loop back to the any VRF. So that will be a part of the global routing table. So if I'm going to delete this loop back, then it will be gone. Nothing will be there. So now I've deleted this loop back. Show IP route. Nothing is there in the global routing table. It seemed like a VLAN concept. So as soon as you're going to move the port from the VLAN number 1 to the different VLAN, one port will be missing in the VLAN number 1.
If Mr. Low, we delete VRF blue, so the ports will return back to global?
That port. So if you're going to delete this VRF using that, normally it should not be. That means no VRF system.
Then we have to reconfigure all the interfaces.
Yeah.
No?
Show IP interface brief. The IP is gone right now because the routing table will be gone, and show IP VRF my interface will be moved to the, it's a global VRF now.
Mhm.
So you need to simply go on the interface and assign the IP addressing. So if you see that do show run interface 0/0, it's gone from here. So you need to do the reconfiguration again. So if you're going to delete the VRF, my VRF will be deleted, all the virtual routing table will be deleted, and that configuration also will be removed from the interface. So this guy is now a part of the global. Blue. Why the red is not coming? Oh, I haven't get the VRF yet. IP VRF. Red. And now assign the ports. So IP VRF. All good now. So once you have done with this part, right, now you have to do the routing. So in the routing, what happened? I can configure this guy as a part of the any protocol you can take it, right? So I'll take a configuration of this guy as a static route over here. And this guy I'm going to configure the EIGRP. Same thing, static and EIGRP. So on the customer side, I'm not going to do any kind of VRF configuration, it's a normal one. So I'll configure this guy as a, so router number 1, he wants to go to the 25, 2.0 and the 2.0 as well. All right. On the router 2 as well, you can also use the concept of the default route over here. On the ISP side, the configuration will be a little different because as soon as I'm going to put this command, that route will be participating into the global routing table. I need to tell this guy on the router 5, hey, listen, the route that I'm going to define over here on the router 5, I need to define these two route and these two route. Because in the static, what happened, everything you're going to define manually. So I'm going to say that, hey, 1.0.0/8, the next hop will be 15.1. So if I'm going to put this command, what happened, they will be moving in the global routing table. I'm going to tell this guy, listen, you are the part of the red routing table. Same way, IP route VRF red. (15.1). On a R2 as well, sorry, on a R5 as well, IP route VRF blue 2.0.0.0. Not blue, red only. IP route VRF red 25.2. That's for the static route for the VRF. Same way you can configure the EIGRP as well. On router number 3 right now, I'll better to configure the 0.0.0.0. Fine, no problem, right? On router 4 as well. No problem. Do not do that in the production network, not even in the lab exam. Never configure it. We are in the practice, we can configure it, but do not do that in the production. On data 5, Because now we're going to do the configuration for the VRF. We need to put the command out EIGRP1 address family IPv4 VRF blue. So I'm saying, hey, listen, you need to now look for the VRF routing table, not the global routing table. And here I'm going to define the autonomous system number. One. As the network, when I say the 0.0.0, it will look in the blue routing table and enable all the interface into the blue routing table, which is the 1/0 and the 4/1 as well. Either you can configure this way, or you can manually define the route. That's all. So on the router number 1, I'll configure this guy. On router number 2, I'll configure this guy. Uh-oh. My bad. Okay. On router 5, we have a lot of things. Router 3, this guy. Router 4, we have this guy. And router 5. Everything is done now. We have a EIGRP membership. Interesting part I want to show you over here. Show IP route. VRF red. Show IP route. VRF blue. What I want to show you over here, the duplicate route. By default, it's not possible. It is possible because of the VRF. So this is the blue routing table. This is the red routing table. Is that clear? Sebi?
Yes. Yeah. And the EIGRP command is just similar to the name mode, right? And for the OSPF, the command is same.
It's not anymore. It's a classic mode right now.
Yeah, classic mode only, but the command is a bit different to the name mode, right?
Yeah, we just
the address family IPv4, that one.
Yeah, right. We'll do that
tomorrow.
tomorrow.
And the OSPF, what is the command? Router.
We have a class. OSPF will do that tomorrow.
Okay.
OSPF and BGP. Okay. OSPF, BGP, and packet flow. We'll do that tomorrow. Don't worry. How the packet flow is working in this VRF, we'll do that.
Okay.
So if you see on the router 3 right now, you will have a router. So router 3 has a route for the router 4. Only router 4, not this side. Yeah, sir, it's clear to you?
Yes, Mr. It's very clear.
It's very clear. Okay, cool. So I'll do one thing. Tomorrow we'll do the lab of the packet flow, how the packet flow is working in the VRF. Then we'll talk about the concept of the, what do we call, OSPF and BGP as well. And we'll configure the name mode as well, not a big problem. And one more thing. Okay, let me stop the recording now.